Welcome to The Explainer. Today, we are diving into a completely fascinating conceptual shift in the world of AI, straight out of Wesley Shu's 2026 paper, From Alignment to Interaction. For the longest time, we've treated AI alignment like a giant puzzle we have to solve before a model is ever released, purely as a training problem. But what if we've been missing half the picture? What if we reframe alignment not just as some static property locked inside a trained model, but as a dynamic, interactive system that actually stabilizes during runtime? Let's get right into it. Here is our cognitive roadmap for today. First, we'll look at the dominant alignment view, then introduce the energetic paradigm framework. After that, we'll explore reasoning as a stable trajectory, unpack 7 theoretical implications, and wrap up with a totally new layer of alignment.
Starting with Section 1, the dominant alignment view. Basically, the status quo of AI training.
So right now, the industry generally treats desirable AI behavior as something you have to bake in during the training stage. We're talking about changing model weights, tweaking reward signals, using preference data like RLHF, running fine-tuning procedures, or laying down constitutional rules. The whole underlying assumption here is that a model's behavior is anchored entirely in its parameters before you or I ever interact with it. It's like the model itself is the sole container where cognition lives. Sure, runtime interaction matters, but mostly just as a way to pull out what's already been hard-coded in. Now, Wesley Shu isn't saying training is irrelevant. Obviously, it's absolutely crucial. But he proposes this really interesting alternative. Training stage alignment should actually be paired with interaction stage alignment. Even if a model's parameters are locked and completely fixed, the way we shape control structures and reasoning regimes during our runtime interactions can organize and, more importantly, stabilize its behavior. Which brings us to Section 2, the energetic paradigm framework. We are zooming out to the system level. Let's clearly define this framework. The energetic paradigm is a dynamical systems framework where repeated interaction among the model, prompt structure, dialogue history, and user steering generates stable reasoning regimes. I know that sounds like a mouthful, but it's a very precise academic reframing. We are no longer just looking at a user shooting off a prompt and a model spitting out a token. Instead, we're looking at a continuous loop, a discrete-time dynamical system, where the model parameters are fixed, but the interaction controls are highly variable. Think of it this way. Within this framework, dialogue isn't just a series of random, independent responses drawn from a hat. It's an interaction flow. The constraints, the attention, the dialogue history, and the user steering, they are repeatedly redistributed turn after turn. Eventually, this corrective pressure actually settles the system down until a stable mode emerges. And the implications of this are huge. It means that intelligence and alignment itself belong partly to this coupled model-prompt-user system. It's not just sitting inside the isolated model. It's a shared environment. Moving on to Section 3, reasoning as a stable trajectory. We're going way beyond single-turn elicitation here. So, how do we actually define a reasoning mode in this context? Well, a one-turn answer? That's not a mode. A true reasoning mode has to persist across time. It is a persistent trajectory-level regime. You kind of have to stop thinking of it as a momentary tone or a quick style choice and start seeing it as a sustained cognitive structure. It's a state that the system actively maintains over an extended dialogue horizon. To understand how this works over time, we borrow from dynamical systems theory, specifically the concepts of attractors and basins. If your interaction protocol sets up the right constraints, the system experiences a contraction toward a stable state. Basically, it falls into a basin of attraction. And here is the truly wild part. Repeated interaction can stabilize these reasoning modes without a single weight update, zero retraining. The system just settles into this stable cognitive structure naturally, purely driven by the architecture of the interaction itself. Okay, Section 4, 7 theoretical implications. We're extending alignment right into trajectory space. The paper actually proves these implications mathematically, and they are so fascinating. First up, fixed weights do not imply fixed long-run behavior. Second, like we just said, repeated interaction can stabilize coherent reasoning completely without retraining. Third, and I absolutely love this one, multiple, totally distinct stable reasoning modes can exist within the exact same trained model. It just depends on the interaction structure. And fourth, tiny, small changes in interaction control might produce sudden threshold-like shifts between these modes. Let's double-click on that fourth point for a second, this idea of threshold-induced switching. In parameterized dynamical systems, when you cross a critical threshold, you get a massive qualitative transition. For us, that means minor tweaks to your prompt structures or your ongoing interaction parameters aren't just superficial little style changes. No, they act as triggers. They can push the entire coupled system right over a threshold and drop it into a completely new, stable reasoning regime. Wrapping up the implications, number 5 shows us that once these modes are stabilized, they're tough. They remain resilient against bounded disturbances, like when a user throws in a local distractor. Number 6 tells us that modern alignment really needs to be a dual-layer approach. You form the capabilities during training, but you select the regime during runtime deployment. And finally, implication 7 gives us a highly formal, rigorous way to look at algorithmic metacognition. I want to take a quick second to clarify that last point about metacognition. Usually when we hear that word, we picture a glowing, self-aware brain pondering its own thoughts, right? Well, scratch that. The energetic paradigm defines algorithmic metacognition way more practically. It's strictly about the measurable, structural selection and regulation of interaction parameters. It's just a system controlling which reasoning mode it inhabits, rather than relying on some sci-fi anthropomorphic idea of self-reflection.
And that brings us to Section 5, a new layer of alignment, capability formation and regime selection. Honestly, if you only remember one thing from this entire explainer today, it absolutely needs to be this core thesis right here. Quote, "The model determines what is possible, the interaction system helps determine which stable form of reasoning becomes active." It's brilliant. Training lays down the boundaries of what the model can do, but it is that coupled dynamic interaction flow that actually picks and stabilizes the reasoning regime you'll see in the real world.
So, as we've seen, intelligence isn't just locked in the weights. It's a shared workload spread across the model, the prompts, the history, and most importantly, you. I want to leave you with a question to chew on. If alignment truly is a coupled dynamical system, what stable reasoning mode are you stabilizing in your AI interactions today? Thank you so much for joining me for this explainer, and have fun exploring the structures you're building in your everyday interactions.